In this presentation, what we're going to do is hypothesis testing. Okay. Now, so suppose a well-known polling company predicted that the percentage of voters in favour of some constitutional amendment in Ireland. We have a lot of these sort of referendums. So supposedly it is 60%. Let's say. Okay. Right now. Let's just move on. So it's 60%. Now let's suppose that the same polling company carries out another poll 1 week later. So things have changed over the week. So we want to sort of run the analysis again, run the poll again, and just sort of see has there been any change. So what they found is that in the second poll, okay, so just let's start off with the basics here. 1,000 people were interviewed. That gives us our sample size. N is equal to 1,000, okay? And of the 1,000 people, 570 are in favor, okay? So it's not been explicitly stated yet, but what we're looking at here is proportions, okay? Okay, so it's a single sample proportion, okay? And we're just sort of reading it and we go and we're just picking up all these little pieces of information. Okay, so that gives us our point estimate. Okay, so that's quite important. 570 out of 1,000. Okay. Now, test the hypothesis that there has been a change in the true proportion in favor of the amendment. Okay, so this is a hypothesis test. Now, something that's important here is that the wording is change. Okay, so that's important because it's not. I didn't say a decrease. I didn't say an increase or anything like that. I said a change. Okay, so a change could be a decrease or an increase. Okay. Now, finally, just actually, you might get stated somewhere to told use some level of significance. I'm using 5% significance. Okay, so you probably might get to assume 5% significance if you're not automatically told. Okay, so first off, we're going to write out our hypotheses. Okay, and we always write out our hypotheses in terms of the parameter values. So I'm going to use P for the true proportion or the population proportion. Okay, which is different from the sample proportion. Now, some textbooks use pi. P or pi, much of a muchness. I use P just because it's a little bit easier to write. So P equals 0.60. Okay, that is to say, this is at the time of survey. That's important. So there's been no change from last week to this week in terms of the true proportion. Okay, so that what we're saying there is that there is no change in the number of people in favor. Okay. Now, the alternative hypothesis is that there has been a change. It has changed from 60%. Okay. So, it could be greater than 60%. It can be less than 60%. Anyway, change. The null hypothesis says no change, and the alternative hypothesis says change. P equals 0.60. P not equal to 0.60. Now, just actually, it's always worth your while just writing out some sort of description. Okay, you can rephrase it in different ways. It doesn't. There's no sort of one set way of phrasing it. So, as well as the mathematical notation there, which we have up at top, just put in a little discussion. Okay, always helps. Okay, so no change in proportion in favor of referendum amendment or something like that. Just some sort of discussion, as long as it makes sense. There's no right or wrong way, as long as it makes sense in the context of the question. Or there's not only one right way. Okay. So that's an important step. There's no actual calculations there. Okay, we're going to do all the calculations here. So what we're going to do is calculate the test statistic. Okay, so there's two parts to this: expected value under null hypothesis. Okay, so we under the null hypothesis where there's been no change from 1 week to the next. We expect the true proportion in favor to remain as 60% or 0.60. Now, but when we did carry out our survey, we did find it that we found 57% in favor of our 1,000 people. So this is the sample proportion here. Okay, so that's we're going to use that in our test statistic. Okay, so our observed difference. So anyway, just actually remark our sample size is 1,000. Okay, that's just worth bearing in mind. Okay, now so our test statistic is our point estimate minus our expected value under null, okay, all over the standard error. Okay, now that's the general gist of it. So we can already tell point estimate minus expected value under null hypothesis. We can already tell that's going to be a minus 3. Okay, so I'm going to work in terms of percentages, because just actually you'll notice this when you're calculating standard error, that when you work in terms of percentages, it actually, the number crunching, it gets a little bit easier. So 57% minus 60% all over this standard error. Okay, so I'm not finished yet. So essentially what I have to do now is, this is where I am. It's minus 3 over something, but essentially what I have to do now here is go to the back of the exam paper now and pick out the standard error. Now, careful. Okay, this is where you can go wrong. One formula for confidence intervals, CIs for confidence intervals, another for hypothesis tests. Okay, so this is one particular case where you have to be careful. Okay, we're not carrying out a hypothesis, or we're not carrying out a confidence interval procedure. We're not calculating any confidence intervals. We're calculating the standard error to use in a hypothesis test. So that's just something to be super careful of. Okay, so essentially the standard error in this case is based on the actual expected value under the null hypothesis, p times 100 minus p, that's the complement of p, all over n. Okay, now p here is the expected value under the null hypothesis. Okay, if we were carrying out a confidence interval, we'd use the point estimate p hat. Just watch out for that. That's where things can go wrong. Okay, not that you lose that many marks really, but like, you know, just be careful. So that's just the one thing to sort of look out for. So under our null hypothesis, we expect 60%, okay, times 100 minus 60 is 40, all over 1000. Okay, so there we are. This is just a little bit number crunching now. 2400 divided by 1000. It's the square root of 2.4. I'm just going to pause this a second because I forgot to calculate that. So, just a bit of calculator work. I'm going to just call it 1.55. It's not, I'm just going to round it down a bit, okay? So, or round it up. So, I reckon that I calculate the standard error to be 1.55. Now, the last bit is, let's just actually sort of calculate the test statistic. The test statistic is 57 minus 60, which is minus 3, all over 1.55. I make that to be 1.93. So that is my test statistic there, 1.93. Okay, so that's that part done. Now you can almost see I'm setting up for the next part here, which is the critical value. Okay, now this step is sort of straightforward enough. Okay, for this particular example, we're dealing with a large sample, and we're always going to be sort of dealing with large samples in the context of proportions. Like small samples only really take place in the context of means. That's as far as undergraduate statistics is commonly taught. Okay, if they're doing small sample proportions in undergraduate statistics, your lecturer hates you basically. So n is greater than 30 because we have 1000. Okay, so that's definitely a large sample. Okay, now it's a two-tailed test, and we're told that the earlier on that the significance value is 0.05. Just as a remark, is it a two-tailed test? Let's go back here. Equals, not equals, that's a two-tailed test. So if you have equals versus not equals in your hypotheses, that's a two-tailed test. Okay, so critical value is 1.96. Okay, so that's the sort of usual critical value for a lot of these procedures. If you actually get stuck with this and have to make a wild guess, 1.96, quite often that would be the right answer. Okay, I'm not sort of advocating bluffing your way through an exam, but like, you know, you still could be, you don't want to be losing marks. Anyway, so it's 1.96. So the last part is the decision rule. Okay, And earlier on, we've seen that the test statistic was minus, where is it? Minus 1.93. Okay, sorry, I went up a bit too far there. Sorry, that's minus 1.93. Minus, okay? Minus 1.93, okay? So is the absolute value of the test statistic greater than the critical value? Okay, so this is where the absolute value comes into play. So is the absolute value of minus 1.93? Tell you what, let's just look at that. The absolute value of minus 1.93 is simply 1.93. So is 1.93 greater than 1.96? No. Okay, we fail to reject null hypothesis. Okay, so not enough evidence to suggest change. Okay, now you might start thinking like, well, that's at 95%. Maybe at a referendum you wouldn't be so like you probably still, if you're a politician in favour of this, you'd probably be still panicky about it. But anyway, just actually what I'm going to remark upon there before I go is this was to do with a change. Okay, the question actually asked for a change. Was there a change? Suppose we were actually asked for a decrease. Okay, suppose the question was posed that way. Decrease in proportion in favour. Okay. So just a slightly different question. I'm not going to do the whole thing out again, but how we would write the null hypothesis is P1 or P greater than 0.60, which is to say no decrease. P less than 0.60 decrease. Okay. So that's just in case we were asked for a change, like a change rather than a change in proportion, a decrease. Has the proportion decreased? Now, just as a remark, everything's pretty much the same as before, except this is a one-tailed test. And there, the critical value would be 1.645, which would give us a different answer this time. Okay, so I went for a very simplistic version first off. Was there a change? But we're asking a much more precise question now, one that has more logic in the context of the real world. And here we get a different example. Here we would sort of reject the null hypothesis that there has been no decrease. Okay, so anyway, so that's important. So essentially, what's going to happen there is you put on the spot a bit more. Like I'll be honest with you, if you don't get the right one, you probably still get most of the marks for your mostly a well presented hypothesis test. Okay, so that's hypothesis testing for proportions.